Design details rarely feel like an electrician's responsibility, but they do have a direct impact on how lighting effects immediately look and how linear systems age. Small physical choices made during detailing or installation can quietly introduce heat buildup, mechanical strain, or access issues that only become obvious after the system has been running for a long time. Design details don't usually cause immediate failure. What they do, first of all, is show the incorrect light beam, as shown here. So we could insert it here. So it looks good from far, but when you zoom in, it looks really bad. So design detail is first of all ensuring that the lighting effect is good. It's not glary, it's uniform, most importantly, and then it's shown in a very neat way. The integration is very neat. So you tend to see a lot of signage companies do a lot of sloppy work, but signage is from far. Nobody's inspecting it close up. So if you're integrating stuff in homes, commercial spaces, you need to be at attention to that design detail. So these design details don't usually cause immediate failure, as I mentioned. They could accelerate degradation and make maintenance or correction difficult later. This lesson highlights the most common design-related red flags that affect longevity, and you need to watch out for them. 1. Heat traps. Fixtures buried in tight recesses where there's no airflow. For example, I've seen recessed LED lighting details where the LEDs are just stuck in MDF or some non-conducting material, and those, if they drop, they'd probably drop off. It loses the glue, that adhesion aspect of it, and it falls off over time, or it just degrades. It becomes spotty or it becomes yellow because we're not managing the thermal management of the LED strip. Now, that's something we don't know unless we have an ultra reliable supplier that has all the standardized testing done, the luminous maintenance, all of these things. And even beyond those tests, they test in a lab with ideal parameters. They don't test in your scenario. Always remember that. When things are tested in a lab, it's tested into X, Y, and Z scenario. And if you're buying a product, it's probably tested under stress under X, Y, and Z standards. So this is why this is critical, that you understand the limitations of lab tested stuff and field tested stuff. So there's no airflow in spaces like that. There could be insulation and finishes enclosing the product that could cause it to degrade over time. Then there's mechanical stress such as tight bends. So some products may not be able to bend all the way, and we don't read the manufacturer's maximum and minimum bend radius. So it might be under tension where it's bending, and eventually the circuit board is under stress, heat builds up, and it just disconnects. So when you're forcing alignment to fit a design intent or tension with connectors and wiring, all of that causes, so imagine wires not making the right connection. Heat builds up and it causes it to fail over some time. And I'm saying this because I've experienced everything under the sun. 3, poor access and no allowance for drivers. So this is a common one I used to see. I can't believe it. I've seen people seal drivers in gypsum ceilings with no way to access it. So you always want to ensure that you have driver, LED driver, or power supply, or transformer access. And fixtures have been installed where removal is destructive, as I mentioned, such as breaking down gypsum walls and what have you. Also, controls or other things should be serviceable and accessible. So all of this makes up the design detail. So 1, where is it going? Are we using the correct installation method to get the right lighting effect? Is the cavity being built properly? Is the cavity a material? So I'll show you an example here. This is a stairs lighting detail, and you could see that it's a public space. It should be in an enclosed aluminum fixture. The architectural detail for the stairs is not the best. So it should be in an enclosed fixture so that if there's any cleaning or exposure to dust or just mechanical damage by somebody's foot hitting it, the LED circuit is going to blow. And if you look carefully, you may see where the wiring is coming out. So that's also a design detail issue. The wire shouldn't be exposed because that acts now as a point for destruction. That wire should integrate nicely into the fixtures. And you can see now that this device is blown because the cleaners came in after this job and used their steam cleaner and destroyed everything. So this is a good example of what not to do. So the key insight here is that LEDs need to be as perfectly designed as possible to achieve long-lasting lighting effect and room to breathe and be serviced in the future. Before final installation, I want you to walk through the site, to walk through a past job and think, is the lighting effect correct? Where will heat accumulate? What will be the hardest to access in 3 to 5 years? Most likely it's the wiring. Which detail looks good now but will be painful later on when the finishes go in the space? So it looks good, and then when the finishes go in and you see all this bad work, So if any of these questions or any of these answers causes hesitation, document it before proceeding. Design details rarely feel like an electrician's responsibility, but they do have a direct impact on how lighting effects immediately look and how linear systems age. Small physical choices made during detailing or installation can quietly introduce heat buildup, mechanical strain, or access issues that only become obvious after the system has been running for a long time. Design details don't usually cause immediate failure. What they do